Hello, we're going to work on some lesson 3.03 today and be learning about quadrilaterals. These are some of the objectives that we're going to be going over. Identify the relationships among special quadrilaterals and among their properties. And we're going to use properties of special quadrilaterals to solve problems. Some of the terms are terms that you're probably pretty familiar with: a parallelogram, quadrilateral, rectangle, rhombus, square, and a trapezoid. And let's get kicked off talking about quadrilaterals and their properties. The word diamond is usually used to describe a certain four-sided figure, and when most people hear the phrase baseball diamond, they picture something like the baseball diamond outlined here in red, right here. That's what people consider a diamond. In reality, this diamond is a square, and we classify special four-sided shapes with their own unique side and angle relationships. A quadrilateral is a four-sided polygon, and you name it by writing each vertex in consecutive order. So you look for the vertex, and basically when it says consecutive order, that means in the order they appear. And we always try to write them in alphabetical order. So we wouldn't go A, D, C, B. We wouldn't want to do that. So we write A, B, C, D. Of course, these are the three different ways you could name it. And you could name it D, A, B, C or C, B, A, D, but most math people are used to seeing it in alphabetical order. Okay, we're going to get started off with a parallelogram. It's a quadrilateral with two pairs of parallel sides, and the arrows in the diagram show which sides are parallel. So here where you see one arrow, those sides are parallel, and then where you see the two arrows, those sides are parallel. And a parallelogram just looks like a slanted rectangle. Okay, let's talk about all the properties of a parallelogram. First is the opposite sides are congruent. Okay, like here the examples they gave is EF is congruent to HG, and I think this is wrong right here. This should say HE. Let me fix that. Let me come over here. I'm going to get this bright yellow. And I'm going to change this right here. Well, let me make it italic so maybe it'll lean like that G's leaning. I'm going to type an E in there, but of course it needs to be a little larger. There we go. There. That should be an E. And I'm going to copy that because I know it's going to be wrong on the next slide too. Okay, so, and they're saying HE is congruent to FG as well. Now on this one, oops, I gotta have it on the pointer. There it goes. Okay, the opposite angles are congruent. So if you look right here, let me get my pointer back. You've got angle E right here is going to be congruent to angle G. And then you got angle H is congruent to angle F. And then on our next one, I just keep coming in and I'm changing this to an E every time so that way y'all won't get confused. It says the consecutive angles are supplementary. So what they mean by consecutive is E and F are consecutive, F and G are consecutive, G and H are consecutive, and H and E are consecutive. That means they're next to each other. Not next door neighbors, but right next to each other. So they said the consecutive angles are supplementary, so that means the measure of angle H and G are 180, G and F are 180, F and E is 180, and E and H is 180. Okay, the next one says that diagonals bisect each other. And I put this up here. It says diagonals are line segments whose endpoints are on non-consecutive vertices. Pretty much on a parallelogram, non-consecutive means opposite. So the diagonals bisect each other. So you got right here that EJ is congruent to JG, and HJ is going to be congruent to JF because they bisect each other. Okay, now let's talk about rectangles. A rectangle is a parallelogram with 4 right angles. All the properties for a parallelogram are true for a rectangle. So everything we just learned right here, all of these are also true for a rectangle. But there is an additional property just for rectangles, and that property is that the diagonals are congruent. So if I'm looking at a parallelogram, EG obviously is not congruent to HF. EG is shorter, okay? But when you're working with a rectangle, those diagonals are going to be congruent. Okay, so not only do they bisect each other, they're the same size. So MP is the same size as QN. Okay? And rectangles, of course, always have the 4 90-degree angles. Let's look at rhombi. A rhombus is a parallelogram with 4 congruent sides. Okay, so you think a square is also a parallelogram with 4 congruent sides, but there's something that makes a rhombus different. Of course, it has all the properties of a parallelogram that we learned earlier, plus this one. The diagonals are perpendicular, always. So if we wanted to say that that was perpendicular, we could come add the little square right there. And then we would know that all 4 of those angles there are 90-degree angles, and that's what I've listed right here. Okay. And something else that's nice to know about diagonals of a rhombus is that they bisect the vertices. So that means, let me get my pointer, that this angle right here, which would be WZV or WZX, this angle right here is going to be congruent to this angle over here on this side. Okay, these 2 angles are congruent to each other, and these 2 angles are congruent to each other. Okay, because that diagonal bisects the vertices. Remember, bisect means that it cuts into 2 equal parts. Now we're moving on to squares. Now a square is a parallelogram with 4 congruent sides and 4 right angles. That means it is both a rectangle and a rhombus. Okay, so that means a square has all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. Okay, so you need to know those properties. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides, and you can see that with the zeros. And a trapezoid is not a parallelogram, so it doesn't have any of its properties. Now here's a Venn diagram showing all the quadrilaterals. If you got this Venn diagram right here, see how quadrilaterals is written out here. Trapezoids is all over here all by itself in its own little circle. And the reason that is because it doesn't have any of these properties over here. So in this red circle you see parallelograms. Okay, they include rectangles and rhombuses. Actually, that should say rhombi, not rhombuses. That's very incorrect. And I didn't make this Venn diagram, by the way. So, and then here's a square. It's inside the rectangle circle. It's inside the rhombi circle. Okay, so squares have all the properties of rectangles and rhombi. Rhombi, squares, and rectangles have all the properties of parallelograms. Okay, that's how it works. Summary: a quadrilateral is a polygon with 4 sides. Parallelograms, rectangles, rhombi, squares, and trapezoids are all types of quadrilaterals. You should be going through and reading the lesson in the LMS and completing the student guide. Remember, you get to use your notes on your test, and the student guide is an excellent source for notes. Be sure to read 65 through 68 in the reference guide. Here's the problems you need to complete in the problem set. And if you still have questions after you complete those, please give me or contact me or attend TOGA tomorrow afternoon so you can get help before you take the 3.03 quiz. And that's it for this lesson, and thanks for listening.